Welcome to Azure DIY, Season 4, Episode 1. My name is Gary Buckmaster. I'm a technical architect based at the Microsoft Technology Center, and I'm your host for this particular session, Making Security Easy with Security as Code. Yesterday, we talked to the folks from Lab 3 about the business lens of security in context. They were talking about their approach to security in the 21st century. Today, we're talking to Casey Mullineaux from Lab 3, and he's going to go under the covers of their technology. He's actually going to pull up the hood. He's going to show us how they built out the security as code, the security or this Azure Sentinel as code product. But since it's a brand new season of Azure DIY, I wanted to give you a preview of what we've got in store for you. We built out a really big season. So this is the first episode, making security easy as security with code. But we've also got amazing opportunities to talk about Azure IoT, especially using Azure Sphere. We've got rapid development on the Power Platform, as well as some machine learning operations. Join our community on LinkedIn. Go and take a look. Register for all of the sessions. We're really excited about this season. We've got a lot of new partners that are here to present their solutions. And again, this is meant to be a very deeply technical set of sessions that are aimed at our developers and our technical community. If you haven't already, definitely join our LinkedIn community. The link is here on the page. Join the LinkedIn community. This is also your opportunity to interact with us, get some questions answered, find out what's coming next from Azure DIY. Also, a couple of quick things for housekeeping. This session will be recorded and it'll be shared on LinkedIn. We will also be fielding questions and answers throughout the session. So go ahead and pop your questions into the chat right now or as the session progresses. If we can get them answered for you straight away, we will. Otherwise, we'll definitely have a Q&A session with Casey at the end. So pop your questions in now. Last but not least, there's going to be 10 minutes for that Q&A session, so don't feel like you can't ask your question. We have a lot of opportunity to do that Q&A. One of the great things about Azure DIY has always been the robust Q&A that we have from you, our listeners, asking lots of deeply technical questions. So welcome to Season 4. We're really excited to have you. And speaking of excited, I'm super excited to have Casey Mullineaux join. I've known about Casey for a long time, and we've had this online relationship of deep respect. When he joined Lab 3, I was excited to see him join, and then almost immediately they rolled out this Azure Sentinel as code product. So I'm really excited to have Casey be able to come on now, be able to show exactly the work that he and the team have done over at Lab 3, and really wanting to see exactly how this solution was built out. So Casey, welcome to Azure DIY. Really excited to have you.
Thanks very much, Gary. Let me just share my screen up here. Okay, hi everybody. My name is Casey Mullineaux. I'm a principal security engineer here at Lab 3, and I'm also the product lead for Sentinel as Code. For those of you that don't know us, we're a technology provider specializing in cloud-based solutions. We empower organizations to drive greater business value with controlled and scalable technology. Our focus is heavily on DevOps practices, and we look for opportunities for automation wherever possible. We leverage infrastructure as code for solutions such as Windows Virtual Desktop, Sentinel, and Azure Landing Zones based on the Azure Cloud Adoption Framework. So that brings us to the topic of today's talk, Sentinel as Code. So what is Sentinel as Code? Well, it's a declarative approach to deploying and configuring Azure Sentinel. Think of infrastructure as code applied to security tools. It uses DevOps tools and practices such as CI/CD and Git flow to ensure our code is of high quality and our deployments can be created and deployed quickly. Lastly, there was a design focus to ensure that it was easy as possible to create, modify, and maintain. So why did we create it? Well, we knew that if we applied our skills and experience with automation to security, we could help organizations provision the infrastructure and tooling they need to protect themselves from cyber threats. So that meant we needed to be able to deploy fully configured and customized Azure Sentinel environments to multiple tenancies quickly and consistently. Along with that, we also wanted to create a reusable library of components that would build up over time, that would speed up deployments and continue to deliver additional value to our customers. I'm going to tell you a little bit about the story of how we got to where we are. So in the beginning, we were deploying things we were deploying and configuring Sentinel using a bunch of different PowerShell scripts. Those were procedural scripts that evolved over time as we started to begin to automate the configuration of different components of Sentinel. Over time, our scripts became super complicated, and they were tying together a bunch of different methods used to interact with Sentinel. We'd use PowerShell commandlets for one thing, and when commandlets weren't available, we'd be hitting APIs directly, which would require we submit JSON documents as configure items to the API. It was a bit of a mess. It eventually got way too complicated to create new deployments and to keep updated or add any new features. So that's what led us to create our first design principle. We wanted a unified approach to deploy and configure all of the components of Azure Sentinel. We wanted one method that would work for everything. So we started looking to some of the tools that are really good at this, such as Terraform. It's got a great, easy to understand language that can be used to deploy a huge range of Azure resources. But unfortunately, we quickly found out that it didn't meet our requirements as there weren't any providers for Sentinel available at the time. We either had to wait for the community to create them and hope they did what we wanted, or make the providers ourselves, which we weren't really interested in doing. That would have just diluted our focus away from the things we're really trying to achieve. So unfortunately, that one was out. And that's what drove us to our second design principle. Whatever technology it was, or technology or tool that we select, we needed to have an active support for new features. With Sentinel at this stage now starting to release new features and integrations with third-party products, we wanted to be able to incorporate them into our code as quickly as we possibly could. To achieve that, we couldn't be limited by our tools and the hopes that someone else was going to create the integration that we needed. Next, we took a look at ARM templates. They were a unified way to provision all of the Sentinel components, and they had the full support of Microsoft. So first two design principles, check, check. So we gave that a try. Now, ARM templates are configuration documents that are written in JSON. JSON is a language that was created for computers to be able to talk to each other. It was never intended for humans to be creating configurations manually. If you've ever created deployments with ARM templates before, you'll realize that they can get out of hand really quickly. Some of our deployments got so large, you wonder if there was any demonic outside forces dooming you to fail. Writing raw JSON from scratch is hard, and it was too easy to make mistakes. You forget to close a string, or you leave a comma out, and the entire deployment would fail with an error that would give you no insight to where the problem was. Whenever we had to create a new deployment for a customer or make any changes, this is a feeling that was common amongst the team. And that formed our third design principle. Our deployments needed to be easy to create, configure, and maintain, and we wanted our code to be deployable by as many people as possible. Now, it's easy enough for it's not easy, but someone with an engineering background can kind of decode an ARM template and figure out what's going on. But our code was actually in the hands of others, not without such strong engineering skill sets. So our security experts here at Lab 3, they don't have such a strong development background, but they're incredibly good at security. So when it comes to doing deployments, sometimes they struggled with coming to terms with how an ARM template would work. And also, we often would give our code to our customers so they can manage and maintain their own deployments of our software, and they often saw the same challenges. And then Bicep came along. Bicep is a new domain-specific language, or a DSL, currently in development by Microsoft, that acts as a transparent abstraction on top of ARM templates. The Bicep language is very Terraform-like, and it's really, really easy to use. It significantly reduces the complexities around writing our configurations. It combines all the good things that we love about Terraform with the flexibility of ARM templates. In choosing Bicep, it gave us a unified approach to deploy all our Sentinel resources. It gave us day zero support for new features from Azure Sentinel, and it was easy to learn and use. And that brings us to the Sentinel as code architecture. Like, what are we doing with our code base? Now, the way it works is we start out with a main Bicep template. This acts as like the orchestrator template that deploys all of our modules. We use what I like to call atomic units of code, which means we break down components into smaller modules until they can't be broken down any further. We then create a separate bicep module for each configuration of all the components that are being deployed, and we repeat that for each of the components. We then take that main bicep file that orchestrates all the modules and configurations and compile them down to a single ARM template using the bicep build command. We take that ARM template and run it through an ARM template testing toolkit. And finally, if all the tests pass, we deploy that into Azure. Now, I'm going to run you through really quickly the demonstration I'm going to be giving today and how that's going to work. So I have Sentinel as code deployment ready to go and stored in source control in Azure repos. When I start the deployment pipeline, the build stage will run, and that bicep build command will compile it down to an ARM template. It will run it through the testing framework and trigger a deployment into Azure. The deployment will first deploy Sentinel, and then within Sentinel, a data connector will be configured that reaches out to a taxi-compliant threat intelligence feed and populates our log analytics workspace with threat intelligence. An analytic rule will query that workspace every 5 minutes, and when it returns a result, it'll create a new security incident. Upon the creation of that incident, an automation rule is triggered and will fire off a Sentinel playbook that calls a REST API, and that API is going to make all the lights in my office here flash red. So I've got a lamp sitting next to me here, which I got from IKEA. So that's going to run every 5 minutes. So if you see things starting to flash red, then it's worked. So now it's time to get into the demo. First thing I need to do is start the build. Hey Siri, start the demo.
For how long?
Whoops, that's not the right one. Let's try that again. Hey Siri. Hey Siri. 1 second, guys. Hey Siri, start the demo. Here we go.
I've started the build in Azure DevOps. Good luck with the demo. You're gonna kill it.
Oh, thanks, Siri. Okay, so that would have triggered our build. So just wait a second, we should see that start.
Sure thing.
I'm not talking to you. Well, hopefully that starts. Let's give that a refresh. There we go. The build's now started. So while that runs, let's dig into the code. So I'm going to start with our main.bicep, and this is what that looks like. Now, if you remember from before, this is our orchestration script. This is the thing that ties all of our little atomic units of code together. So the very first line we have here is specifying the target scope for this deployment. Now, normally you would deploy resources into a resource group, but in this particular demonstration, I'm deploying the resource group along with the resources. So I need to specify that my deployment is targeting a subscription. It's a subscription deployment. The next thing we have is a couple parameters which define the location and the name of the resource group that I'm going to provision. Now, I've specified these as parameters because I may want to change what those values are depending on the environment that I deploy into. And the way that you pass in a parameter value into a bicep file is exactly the same way that you would do it using an ARM template. So if you take a look here, I've got two parameter files defined, both for my development and my production environments. And this is a typical ARM template parameter file structure, exactly the same one that you would use for an ARM template. You can see here I'm giving in my development environment, I'm giving the resource group one specific name. And then in my production environment, I'm giving it a different name. So now we'll move on. So this is the resource that deploys the resource group. And the way that Bicep handles deploying resources is first you define the resource provider. This is using the Microsoft.resources resource provider. Then we define the resource type. I'm deploying a resource group from that provider. Then we have the API version to use, and we pass in a couple of the parameters to create that resource. So you'll see that repeat as we move through. Now, the next thing we're deploying here is a module. And this is one of those modules that I show. It's breaking down. Oh, there we go. We've got an incident, guys. So that's working. So Sentinel, so we're deploying Sentinel as the next thing. So this one's a bit different. It's not deploying a resource, it's deploying a module. And a module you can just think of as another bicep file. So the way that we reference a module is we say, okay, go into the modules directory and load this other external bicep file. We want to scope this deployment to the resource group that we deployed earlier. And we're going to give that a name of module Sentinel here in this case. Now, this is really important to have a really good naming structure for your modules. And I'll show you why when we go and look at the deployment. So from there, my Sentinel module requires a parameter, and that parameter is the location of where to put my Sentinel resources. In that case, we're passing in the location of the resource group that just got deployed. So let's go take a look at this module. So go into my modules directory and look at my Sentinel bicep. So this file contains all the things that exclusively have to do with Sentinel. So if something goes wrong in terms of my deployment, then I know exactly what file to come look into, at least if it's a problem with Sentinel anyway. So the first thing that we're doing is deploying our Log Analytics workspace, and that's using Operational Insights Resource Provider, Workspaces, that API version. So what a Log Analytics workspace is you can kind of think of it like a database of sorts. You insert or you pull in a whole bunch of logging information, and that will translate that into a bunch of tables, which you can then run queries against and extract data from your logs. So we deploy the workspace, we give it a couple of properties about how long we want the retention to be and how we want to pay for it. Then we move on to a Log Analytics solution. So this is actually what Sentinel is. Sentinel is a solution that is provisioned kind of on top of a Log Analytics workspace. There are other types of solutions available for Log Analytics workspaces. Say, for example, that you're ingesting all of your performance metrics into your workspace. There are other solutions like Azure Monitor, I think, that you can install in that workspace that helps you kind of gives you context around that particular type of information that's stored in that workspace. So when it comes to Sentinel, we know that all of our logs going in there are security-related logs, and Sentinel gives us that security lens around all the events and things that are flowing through our workspace. So that's our Sentinel deployment. Let's come back to the main bicep. And the next thing that we're doing is we're deploying data connectors. So I've named my module connectors here, and that's stored in my modules directory in my connectors bicep, and I've given that a nice name. And that requires a workspace parameter of the Sentinel workspace name. Now, one really cool thing about bicep here is if I go back into here really quickly, look at my outputs, I deploy my workspace, and then as an output, I'm sending back the name of the workspace that was created. Then in my connectors module, I'm referencing the name of that workspace. And the cool part about doing that is that if I'm referencing an output of another module, it will automatically create for me the dependency, because that Sentinel workspace has to exist first before I can deploy my connector. I don't have to worry about adding the dependencies manually. So let's come into connectors. So this one's pretty simple, and it's doing exactly the same thing. All my connector deployments, like all the different connectors I might want to deploy, would be referenced here in this connectors bicep file. And in this case, I'm only deploying one connector, which is our threat intelligence connector. And that's what's going to go and talk to that taxi feed. So when I go into the definition of this, this module, I go into my connectors directory and I take a look at taxi anomaly. And this one's a little bit more complicated. So I'm specifying a parameter, which is that workspace name, which I'm inputting from the output of my Sentinel workspace. And then I'm calling this taxi server, and I'm making a whole bunch of different configurations for the connector to connect to a whole bunch of different collection IDs. You can see here these are a bit different as we scroll down. And what each one of those collection IDs, it's basically different threat intelligence for different purposes. You see here, this one's relating to Tor exit nodes. This one's has IP addresses relating to ransomware, CNC servers, it's command and control, things like that. So we're configuring a whole bunch of different collection IDs for this one connector to pull in from all this information from all these different sources and make them available for us to query in our Login Linux workspace. So let's go back to our main bicep and take a look at what's next. The next thing that we're deploying is the playbook. And you can see here, this also references the output of my Sentinel deployment. It needs that workspace because it needs to know which workspace to deploy my playbooks into. So this is defined in my playbooks bicep, as you might expect. So I can come over here to my playbooks bicep, and I have one playbook defined here. This is my playbook that flashes my light spread. So we can drill down into the definition of this playbook, which is in our playbooks directory under flashlights red. And this one also is a bit complicated. So a playbook in terms of Azure Sentinel is a series of automated steps that you can execute given a particular analytic rule that that runs or alerts on some information that's in your Login Linux workspace, or based on the creation of an incident. So the steps that I'm performing here is, like I explained in the slides before, is just hitting a REST API, which triggers these lights here. So one thing that's important to note here about this particular playbook is I'm assigning it a system assigned identity. So when this gets deployed, the playbook itself is going to have an Active Directory object assigned, like its own identity for the playbook. And what that means is I can assign this playbook permissions. So we've got a pretty arbitrary example here about flashing lights, but I mean, think of this in the context of incident response. So let's just say, for example, you might have an analytic rule that is querying your logs, and it detects a possible or even a confirmed brute force password attempt. You've seen one account that's logged that it's tried to attempt to log in like 100 times within a minute. That's something that's probably not a user doing that. It's probably something a bit suspicious. We can use this playbook to automate the response to that particular attack. So we might, firstly, query Active Directory, grab all the user information about that user that's being attacked. We can then email their manager saying that this is going on. We can automatically disable their account, and we can send them an SMS letting them know to contact security because we believe you've been compromised, and get that information that way. So that's really the power of what playbooks can do in terms of automated response within Sentinel. So let's continue. The next thing that we do is we assign some permissions. So we have that playbook, and if you really quickly go back and have a look, you see here on this one, if you go down the bottom, I'm outputting the ID that gets created for this workbook, and I'm also outputting the principal ID that gets created in Active Directory for the account that's behind this this playbook. So that's what allows me to assign it permissions. So now if I come back into my role assignments, this is where I'm referencing that object, and I can assign it to an Active Directory role. And in this case, I need to assign it some roles. I need to assign it a role or a permission to Azure Sentinel itself to be able to read information from the workspace, because by default it's restricted. So by giving my playbook permissions to read that, it's going to allow that to trigger on the incident when that gets created. And there's another permission that we're assigning here, and that's also to allow Sentinel the ability to execute playbooks. So some permission assignments there. And back in main.bicep, we finally have the analytic rule. So analytic rules are the KQL queries that run against the data that's in your workspace, and then they can raise alerts and create incidents depending on certain thresholds and that sort of thing. So if I go into my analytics bicep file. You see here, I'm taking some parameters as inputs, and I have only one rule defined here. In a typical deployment, we would have, sometimes hundreds of analytic rules that we deploy into a Sentinel environment that looks at all sorts of logging activity for things that might look suspicious or be anomalous. And this is where we would reference the deployment to use all of these. So let's take a look at that rule. So under my analytics folder, I have my demo rule, and this one's a little bit more complicated. So we're passing in a couple of parameters. That's fine. Now, what I've got here is, notice that all these parameters don't have a default. When you have a parameter defined that does not have a default value, it means that that is mandatory. You must specify that value when referencing this this module. But these ones here, we've given it a default. So I don't want to always define what these defaults are. I like to create my templates or my configurations with what I like to call sensible defaults. You can change them at any time during deployment because they are parameters overall. After all, you can override them. But by creating a list of sensitive defaults, it means that there's kind of less work to do. I can set up a baseline and then continue with that. So that's how we define a default parameter. Now, the next thing that we have here is what we call decorators. A decorator allows you to define metadata for any particular parameter. So you can see in this case, I'm defining a list of allowed values for this severity parameter, and I've given it a default of high. So by setting my allowed values, it means that someone can't come in and set my severity to something like, Steve, because that's obviously not going to work. I define a couple more parameters here. I've got a couple more things going down here. And then this is really the guts of what an analytic rule does. And that's the rule query. Whoops, the rule query down here. So the analytic rule itself is really defined by what query it runs. So this is just a demo rule, but if I had an analytic rule that might, like I said, look at brute force password attempts, then I would have a rule named brute force password attempts or something like that. And then I would have a query defined, which just checks the logs for that one specific thing. And I repeat that for a whole bunch of different things I might want to be checking for. So the rule query that I've defined for this demo is I'm just querying that threat intelligence indicator table in the Log Analytics workspace that gets automatically created from that connector as soon as it brings in its first load of data. And then I'm just taking the last 100 results. So queries the table, gets 100 results. Then if that alert rule returns greater than 0, which is taking 100, so it's always going to return greater than 0, then I want to create an incident. So that's how we're triggering this. So these are all the parameters and the variables that I've defined, and this is actually the definition of the resource. So we're using the security insights provider, we're using an alert rule type in this API version, and in this section here, we are defining, we're giving it all of the properties of the resource definition, which are all input as those parameter values. So the last thing that this rule does is it creates an automation rule. And what an automation rule is it does exactly what it sounds like. It's a rule that runs some kind of automation based on an event. So in this case, this automation rule is going to trigger on incidents when one gets created, and its action is going to be run a playbook. And that playbook it's going to run is that playbook ID, which gets generated at the creation of that playbook when I deploy it. And then I'm taking the output from that deployment, passing it into this template so it's able to reference that and run it whenever the incident is triggered. So that's the rules. So that's about it for the Sentinel as code configuration. So let's take a look at the build and how that works. So as I mentioned before in the slides, we've got a couple of different stages that our builds run through. the first stage is the build stage. And what this build stage does is it runs that AZ bicep build command, and it takes my my bicep template, takes all the modules and things that I've referenced, it smushes them all together and creates a single ARM template. So what I can actually do is I can show you that in practice. So what I'm going to do on the console here, I'll run AZ bicep build, specify the file name, and I want my main orchestration script. So because this references a whole bunch of modules, which are in themselves other bicep scripts or bicep templates, it brings them all together, and that's going to take that, mush them all together, and output my ARM template. So it's just created this main.json here, and this is the ARM template of all those things. So if we have a look, this thing's pretty massive. This is the type of thing I was talking about before that we would have had to create manually in order to create a rather non-complicated deployment like this one. When you start introducing hundreds of analytic rules and playbooks and those sorts of things, this thing just goes nuts. So one really cool thing about the way that Bicep handles the modules is that it's for every module that you're referencing, it will create a nested deployment within the ARM template. So what that is, it's basically the main ARM template that we're looking at here, deploying another ARM template, and that other ARM template is that module. So we see here in terms of the resources that we're deploying, is deploying my resource group, and then it's executing another deployment resource. The name of that resource is my Sentinel module in this case. And if we have a look at this template block, it looks very much like another ARM template. It's literally nesting an ARM template for my Sentinel deployment inside another ARM template. So that's how these files get so large, and that's how these deployments can get so big. So back over in here, that's the build step. So the next step is we run some tests. So the tests that we're running in this case is the tests that are included in the ARM template testing toolkit, or the ARM TTK. Now, this is a set of PowerShell-based Pester tests. Pester is a PowerShell testing framework that Microsoft provides to check your ARM templates against best practices. So some of these best practices are actually quite important. So we look at one like this one here. Outputs must not contain secrets. Now, this is one thing that's really important. You don't want to be deploying a resource, say a virtual machine, and then in the output of that resource deployment, just dump out the password that you set in clear text. So these tests check for that kind of thing. And another one that's interesting as well is this one here, is secure string parameters cannot have a default. So like you saw in my Bicep file before, you can define default values for your parameters. And if I've done the right thing and I'm accepting a password as a secure object, which means it has to be provided encrypted at deployment time, then it doesn't make sense for you to set a default value in clear text for what that password is going to be. Because if I don't specify my secure variable at a deployment time, then it means I'm going to know what that password is going to be because you've specified it as the default. So if any of these tests fail, then the whole deployment will fail. It won't let you continue. It'll say, nah, go away. Now, this is really good for something that we're using it for when we're talking about our libraries of Sentinel components. So I mentioned we've got these libraries, and what they are basically a big, massive repository of all of the analytic rules that we've created over time. Ones we've sourced from the internet, one we've sourced from Microsoft, ones we've created ourselves internally from our SOC analysts, writing these things for real world events that they're seeing with our customers. And by keeping these things in a library, it means that we can reuse them and provide more value to our customers. If we write a rule for one specific use case, our analysts can submit that code to our library, and that then becomes available to all our customers. And that's also one of the benefits of having, one of our design principles in making sure this is easy to use, because we've got our security analysts, they're security guys, they know that stuff really well, and they're not developers. And they, because this is so easy to use, they're able to contribute to our code base by adding new rules and helping us detect threats for customers, which is benefited by everybody. So with these tests, and because we have other people like outside of our direct team contributing to our code base, we set these tests up to run as a branch policy on our repos. So that means that for someone to contribute a new rule or something, they must first create a new branch, and then when they try to merge their changes into a master branch, it's going to run these tests. And if they're doing anything that's not consistent with the standards that we want to set, then that build will fail and they need to make that change. They simply cannot submit code that is non-compliant to our standards to our code base. And these ARM-TTK tests help us do that. Now, because this is based off the PowerShell testing framework, it's really, really easy to create your own tests. Now, we can create more tests, and we're in the process of doing this actually, to create some tests for our own internal standards, to make sure that everyone that's committing to this code base is not just making good practice ARM templates, but also adhering to things that we internally deem to be important, that's unique to our organization. So that's the ARM tests. So onto the other thing I wanted to show you real quick was when we run the tests, we get this new tab up here in Azure DevOps called Tests. If I click on this test, it shows me the result of the tests that ran on that build. I can see it ran 20 tests, all of them passed. It ran for 3 seconds. That's how long it took to do all those. But what's really cool is you can see I have one run that completed and failed within the last 14 days. If I drill down into this, I can see some more statistics on how my tests are going. So you look at this particular day, there was 2 failed tests that ran. And I can see down here, this is the failing test. In this example, it was what parameters must be referenced. So this again is just a best practice thing. If I'm defining a parameter in my template, then I should use it. If I'm not using that parameter, then it shouldn't be there, just get rid of it. So if I have a look at this, you can see here how my deployments are going. This one specific test passed 3 times on that day, which means I probably ran 3 deployments on that day. And you can see here I ran 21 deployments that were successful on this day, but it failed twice. And this is really important to be able to give you some visibility about how your tests are going. If you've got one test that is consistently failing, that usually indicates a problem with the test itself. Maybe the requirements to pass this test are too difficult and you need to break it down into smaller chunks. Or it might be an education thing. Maybe your team just doesn't know how to write their code in a way that will pass that test. This gives you the visibility of being able to help out with those sorts of things. So let's go back into the build. And our next stage is our deployment. So what I've got going here is 2 different environments. You saw those parameter files before, one for development, one for production, which lets me deploy exactly the same code to both environments, just with different values. And these are the 2 environments for which I'm deploying those into. So this development environment is going to use that development parameters file, but the same code in terms of the deployment. And this production one is going to use my production template file. Now, one of the cool things as well, we've started to add some governance, some change control around deploying our code. That's one of the benefits of using a DevOps approach and the DevOps tools. I've got a deployment gate here on this production environment. It means that someone must manually hit the approve button to go deploy this into my production environment. And that can be backed with some kind of internal change control process like ServiceNow. You can trigger automations to raise tickets and that type of thing to get someone to come in and check. You can have a list of approvers that they're the only ones permitted to approve changes to their production environment. You can set things up like making sure that you can have a check in place that says that you cannot deploy to production either in business hours or outside of business hours, depending on how you want to monitor what's going on. So these tools really help us make sure that the quality of the code that we're deploying to our environments and our customers is always of the highest quality that we can possibly make it. So that's the deployment. Let's go take a look at what happened in Sentinel. So this is Sentinel. If I hit refresh, there's my analytic rule that we deployed. So let's start off with the data connectors. We'll follow the same process. So we deployed this data connector first. If I look at my threat, if I can spell it, threat intelligence, I see here my threat intelligence taxi connector is now lit up, it's green. I can click on this, open up this connectors page, and these are all the different collection IDs that are deployed. So it's reached this connector is reaching out to all those sources and pulling in threat intel from all those places, putting that into our log analytics database. You can see here we've already got close to 120,000 new data points in our log analytics database. So that's the connector. Then let's look at the analytics rule. So here's the analytics rule. You see that it's scheduled. It's of high severity. This is the query that we defined. It's running every 5 minutes. It's looking for the past 1 day's worth of data. It's going to trigger an alert if the query returns more than 0 results. I showed you that before. We have here also, it's going to create an incident from this rule as enabled. So that being said, let's take a look at incidents. So that alert query ran, it detected the query return results, I should say. That then triggered an incident to be created, and these are all the incidents that got created from that alert rule. The next thing is the automation. So this is the automation rule that we deployed. You see here that's what we called it. The actions are to run a playbook, and that triggers every time an incident is created. The playbook that gets triggered is the one that we deployed called AzureDIY flashlights. And we can go into the logic app here and take a look at the steps. And there we go. When a rule is created, send my HTTP request, and that triggers the lights. So that's how you deploy Sentinel's code. But what about making changes to it? I'm going to show you how easy that really is. So let's come back and look at our main deployment here. What I've got here is another GitHub repo, which is our library that we have internally for all of our connectors. We create a separate repo for all of the components of Sentinel, so we can kind of keep all them together. So we go into the modules here. We see here these are all the bicep configurations that deploy a whole bunch of different connectors in Sentinel. So if I ever want to create a new one, I can leverage the work that's already been done in the past. I can take this connector, just copy that, go into my into my connectors. I can paste that in there. I now have this new definition of this connector. Part of the development process is you try to make these as generic as you can, and you input the unique values as parameters. Then I need to wire that up. I need to tell my bicep file to use that thing. So I go into my connectors, and it's as simple as this. I create a new module. I give it a name. Oh, what's this one? Azure Activity. I then reference the location of where that is. It's in the connectors directory. Whoops. In the connectors directory, that's the bicep file. And I'm getting this really rich IntelliSense experience in Visual Studio Code, and that's thanks to the Bicep language service. Now, Microsoft are making Bicep a first-party citizen when it comes to all the tooling and things. So it really does help make these things really easy. So we can see here I'm getting an error. This error is telling me that this module is missing some declarations of some required properties. I have to specify a name, and I have to specify a parameters block. So let's do that. Give it a name. I'm going to call that connector Azure activity. I need to specify a parameters block. Can do that. And now it's saying that this parameters block, oops, where's that going? Is missing some more required properties. It needs a workspace name. And the reason why it's saying it needs a workspace name is because in the configuration here, I've defined that parameter and haven't given a default value, which makes it a required parameter. So come back in here, let's give that a workspace name. I'm going to give that a workspace name of what I'm passing here and save that. And then that's it. I've just added a brand new connector. I deploy that and we're good to go. Really, really easy. Now, the last thing I wanted to show you was when it comes to deployments. So what we're looking at here is the deployment section on our resource group. I showed you before how Bicep takes all your modules and turns them into nested deployments. This is why this is a good thing. And this is also why naming your modules is really important. Because every deployment is a nested deployment, it means that it runs them all independently of one another. Every module is deployed independent of the master template. So what that means is anytime something fails, instead of having one big massive template that just bombs out and gives you some error, you don't know where to start looking, especially if your template's like 8,000 lines long. With this approach, if something fails, it will tell me exactly which module failed, so I know exactly where to start troubleshooting. And another added benefit of doing this is that all of these deployments run concurrently if there aren't any dependencies. So it'll do the dependencies first, and everything else runs concurrently, which means we can deploy Sentinel really, really fast. And just to show you that, if we have a look at this deployment we just ran, our build was 19 seconds, our test was 41 seconds, and our deployment was 1 minute and 21 seconds. So what's that? That's about 2 minutes, 2 minutes, 20 seconds, 2.5 minutes, something like that. So yeah, that just goes to show you how real quick that this thing can happen. So that's it for the demo. Let's come back here. Right, so what I just demonstrated with the lights was a bit of fun, but let's bring this back into context. We deployed Sentinel and configured a data connector that began gathering threat intelligence and made it available to Sentinel. An alert was triggered from that threat intel, and an incident was created. And finally, the creation of that incident triggered automation that performed a series of steps to find in a playbook. You just witnessed going from no security visibility at all to a fully featured, highly customized seam and saw capability in less than 5 minutes. And that, my friends, is the power of Sentinel as code. Thank you very much. I'm Casey Mullineaux, and that was Sentinel as code. Hope you enjoyed.
Casey, great session. First of all, the demos that you just showed were really fantastic.
Thank you.
Just wanted to let you know there's been a lot of questions that have been getting asked in the chat. So some of them you answered during the course of the session. Some of them I'd like to give you an opportunity to sort of address to a little bit more. The first one, of course, was a response to the fact that you've got those guitars hanging in the background. A lot of compliments for the guitars. Question was asked, can you actually play them? And a request was put in specifically by me for you to do Stairway to Heaven. Doesn't have to happen on this broadcast, but at some point we'd like to see that happen. I
can't do that for copyright reasons. I'm sorry.
Fair enough. I respect your decision. Another comment, just as a side, was pointed out that you used Siri, and everybody was having a good laugh about the fact that you used Siri. At the end of the day, it's an endpoint. It's an opportunity for you to pull telemetry sources in. Somebody was suggesting that you're trying to be the next Kelsey Hightower, which I totally respect. Okay, so questions in the chat. First of all, does Sentinel as code also allow for full lifecycle management? And a side question to that was, does Lab 3 provide 24/7 SOC services? I already answered the SOC services because Anthony Wales mentioned that yesterday, but if you want to elaborate on that, and also if you want to elaborate on the lifecycle management question.
So as far as full lifecycle management, kind of. I mean, when it comes to Sentinel, it's not really something that has an end of life. Once you set it up, once it's running, once it's ingesting intel, that's going to be a security team's tool set for the foreseeable future. So while it's never kind of destroyed and recreated or even updated in a major way, you can still use those DevOps tools and those DevOps practices through build and deployment pipelines to make sure any changes you have fit within your internal development policies. And sorry, what was the other question?
The other question was
24/7 SOC.
Yeah.
So yes, we do. We absolutely, for those customers that have that need, we can provide a 24/7 managed SOC that uses our platform that I've just demonstrated today.
Fantastic. Another question was asked, what actual telemetry source are you using to trigger the event that's setting off the red lights? So what dodginess are you conducting?
Well, as a Grandmaster Wizard, I'm not sure that I can let go the spells of which I cast to make this happen. No, but in all seriousness, these are just LifeX bulbs. They're smart bulbs. LifeX provides you with an API that you can just generate an API key and use it like any other web endpoint. It's really, really easy.
Yeah, fair enough. And what are you doing? Port scanning?
Sorry, port scanning.
Yep.
No,
in order to cause the security incident, what's the actual security incident you're triggering off of?
Well, the actual incident we're triggering off was that analytic rule I showed. So the analytic rule, it was a really basic thing, right? It wasn't looking at anything like in a real world scenario. It was just looking at a table saying, hey, in the last 100 results, is there a result? And the answer is always going to be yes, in which case it created the incident and triggered this workflow.
Got it. Fantastic. Lots of questions about what your experience was like using Bicep specifically. It's a relatively new product offering. It's built on top of ARM, which has been around for a while. What was the learning curve like for you guys? What's been the experience in using it? Can you talk to that overall?
Absolutely. So like I kind of mentioned in our journey kind of slides there, we tried a lot of different stuff. But when it came to Bicep, it was incredibly easy for me, who's, I'm used to this type of stuff, to get a hang on. If you've used Terraform before, you could pick it up in like an hour. It's really that simple. It's really that similar to Terraform. Logic's a little bit different, but in terms of syntax and kind of what it's doing, you'll feel right at home. And at least I can tell you from our personal experience here at Lab 3 is, like I mentioned, we've got that this needs to be usable by teams of varying skill sets. And I can tell you that our real heavy security guys that aren't that great with the development stuff, they can create and manage and do deployments with the best of them. And it really, really does please me that that was the end result, because that's exactly what I was aiming for.
Fantastic. You talked about this in the demo. In fact, you demonstrated it pretty nicely, but talk a little bit more about your code development process. So for example, you're obviously using Azure DevOps to do the deployment. What source control are you using? Is it sitting on GitHub? Is it a private Git repository? What are you guys using? You talked a little bit about the way that you do pull requests and manage that. Can you just talk a little bit more about what your software development methodology has been like?
Sure. So we use GitHub for our source control for all of our projects and some of our other products like Azure Bedrock. So we use GitHub. In terms of our source control, we just have branch strategies on there that make sure that all code is peer reviewed. And we have those TTK tests running to make sure somebody doesn't do anything silly, like put some credentials in code. Which is really important, right, to make sure that those checks are in place, especially when it's contributed, the code base is contributed to by people outside of your internal team. You're a lot less aware of what's going on in those circumstances. So yeah, like we just do that stuff, and we have deployment gates again. We have a development environment for which we deploy all of our code into. We also are in the process of building ourselves a completely isolated lab environment with domain controllers and Kali Linux boxes and all those types of things that allow us to simulate real world attacks using the same tools that the bad guys use on a domain environment. We can use it as a training platform to see what logs that come into Sentinel when those things happen. From that, we can simulate attacks that are happening in the real world today. And from that, we generate the queries that look for those events, bring that back into our analytics libraries, and then distribute that to our customers.
Fantastic, really exciting. So another question, and again, you covered this a little bit, but I'll give you an opportunity if you want to elaborate at all. The question was, and I'll say it verbatim, assuming I understand correctly, with this methodology, you deploy a full ARM template on every run, which can be quite slow, although you did it in about 2 minutes, and that was not just a single ARM template, it was a few. How would you approach deploying a single object like a logic app with Bicep?
Well, the same way you'd approach it with ARM templates. Like Bicep literally is just a different language, a different way to create an ARM template. At the end of the day, that's all it does, right? So it really depends on your strategy and what you're trying to do. So if all you want to do is deploy this one thing, just this one isolated unit of a logic app, then just create a Bicep file that does it one thing. Then you can just do you can send that Bicep file off onto the Azure Resource Manager to deploy just like any other ARM template. Microsoft has added support for Bicep files directly into the toolkit, into PowerShell commands, into the Azure CLI. You can deploy a Bicep file directly without doing that decompilation process. The Azure Resource Manager will take that Bicep file and do that for you on the back end and then deploy your resource. So you don't need to do that step in between. So to answer the question, it really depends. For us, in terms of large deployments, they can be slow the first time if you've got a lot of things going on. But with subsequent deployments, if you're just making a quick change here or there, it doesn't deploy the whole thing again. Kind of like how Terraform manages state in Bicep and Azure and ARM templates, Azure is the state. So when you submit your template to the resource manager, it queries the resources that are defined there in Azure itself and sees what you've got and will only deploy the changes. So deployment time really doesn't increase unless you're making a massive amount of changes. And in which case, we don't really have a real requirement for speed when it comes to this type of thing. Once it's deployed and it's up and it's operational, then you're using it.
Cool. One last question that's popped into the chat and it's just come through. So speaking of modules in Bicep, is there any mechanism to publish them as an internal module for internal customers to consume? Think of as in Terraform Enterprise module, for example.
I'm not too familiar with Terraform Enterprise modules, to be honest. But if you want to just create something in one team and make that available for another team to consume, then I guess that just comes down to how you manage your source control. If you store that in a repo that other team members can get at, then let them go grab it.
Fantastic. Look, Casey, this has been a really fantastic first episode for season 4 for Azure DIY. I really want to thank you, first of all, for joining us. It was fantastic. I've always been a fan of yours, and so it's great to meet you, but it's also really great to see all the work that you guys have been doing for Sentinel as code. So thank you very much for that. And for those of you who've been watching the session, again, if you haven't already joined in our LinkedIn community, the link is there on the page for you. We'd really encourage you to get involved. And then also, we always are looking for feedback. Feedback is a massive gift, and this is your opportunity to go and influence what we do next with Azure DIY. What topics would you like to see? How did you think this particular topic went? Was there something that we could have done differently, something that we could have done better? We're always open to the feedback. We appreciate it. And again, thank you very much for spending the afternoon with us from Azure DIY.